In this segment, I would like to explain the concept of completing the square method when it comes to solving quadratic equations. Completing the square method in solving quadratic equations. So the idea is, if I had x square equal to 36, then we know that I can say that this implies x is square root of 36, or this implies x is equal to either plus 6 or minus 6. There's another way of solving the same question. X square equal to 36, so I can write x square minus 36 is equal to 0. X square minus 36 can be factorized as x square minus 6 square is equal to 0. And x square minus 6 square can be written as x plus 6 multiplied by x minus 6 equal to 0, which implies either x plus 6 is 0 or x minus 6 is 0, which means x is either minus 6 or x is equal to positive 6. Now, can I adopt the same idea when I have something like, let's assume I have x plus 2 the whole square is equal to 36. Okay, so if x plus 2 the whole square is 36, then I can say that x plus 2 is equal to positive 6, or I can also say that x plus 2 is equal to negative 6, right? That's because I took the square root of 36. So I can write this as x plus 2 is square root of 36, and of course with a plus or minus sign, because we know that square root of 36 could either be positive or negative. And therefore this would imply x is equal to 6 minus 2 or x is equal to minus 6 minus 2, which means x is equal to 4, or I can say that x equals minus 8, right? So if I can express a given quadratic equation in this form, it really becomes easy to solve the quadratic equation. Let me show you some more examples. Let us assume we have the following quadratic equations. So x plus 3 the whole square is 15. So now if I take the square root on both sides, I will get x plus 3 is equal to plus or minus root 15. And now I can shift the 3 to the other side. So it becomes x is minus 3 plus or minus root 15, which means the roots are minus 3 plus root 15 or minus 3 minus root 15, right? Of course, you will notice that 15 was not a perfect square, but that's fine. Even if 15 is not a perfect square, we'll leave it as root 15. In the second case, we have x plus 2 the whole square is equal to 12, which means x plus 2 is equal to plus or minus square root of 12. Now I know that according to surds, I can write plus or minus 12 as square root of 4 into 3, which is equal to plus or minus 2 root 3. So we have x plus 2 equals plus or minus 2 root 3, which means x is minus 2 plus or minus 2 root 3, like transposing 2 to the other side. By the way, I should have written it as 2 root 3, not 23. So it is 2 root 3 here. Yeah. And therefore I can say that my roots are x is either -2 plus 2 root 3, or it is -2 minus 2 root 3. These are the two roots that are possible. Similarly, in the third one, x minus 5 the whole square is 20, which means x minus 5 will be square root of 20, of course with a plus or minus sign, which means x is the negative 5 transposes to the other side as positive 5 plus or minus root 20. And I can write root 20 as root of 4 into 5. 4 comes out of the square root, so it is 5 plus or minus 2 root 5. Therefore, x is 5 plus 2 root 5, or it is 5 minus 2 root 5, right? These are the two roots of the given quadratic equation. So the main idea here is, if I can express something in the form a plus b the whole square or a minus b the whole square, then it becomes really easy solving the quadratic equation. Now the question is, how can I get these perfect squares, right? That is the main question. How do I get this perfect square on one side and maybe some number on the other side? That is the real challenge, and if we can solve that challenge, then we have a fantastic method to solve a quadratic equation. So now let us learn how to get those perfect squares. I'm just pausing for a few seconds so that you can take a look at what was done on the board, and then we will continue. Okay, now let's understand how to complete the squares. So let us consider these two quadratic equations. First thing that you should do here is always make sure that your coefficient of x square is 1. So in both these equations, the coefficient of x square is 1, which means that we are ready to perform our operations. Now, is it mandatory that it should always be 1? Actually, the coefficient of x square should be a perfect square. But generally, because 1 is a easier number to deal with, that is why I said that you should have the coefficient of x square as 1. So now here what I will do is, I will write this as x square plus this 6x will be split as 2 into x, and now I have to find this particular number here, right? I have to find a number which will make sure that this multiplication is 6x. Not difficult to notice that this number should be 3. Basically the number over here, right, divided by 2. So 6 divided by 2 is 3. Why are we dividing by 2? Because we are already separating out 2 as one factor. So we have x square plus 2 into x into 3 minus 27 is equal to 0. Now what I'm going to do is I'm going to complete the square. So you must remember that a plus b the whole square was given by, let us quickly write the formula for a plus b the whole square. So a plus b the whole square is given by a square plus 2ab plus b square, and a minus b the whole square is given by a square minus 2ab plus b square. So this one now becomes, if you notice, this is x square plus 2 into x into 3. If I need to complete the square, I have a square plus 2a. So let me write it down here. I do have a square plus 2 times a, x is a, times b, right? Now if I want to complete the square, what I should be doing is, I should add the 3 square, right? This 3 square basically would become my b square. But did I have this 3 square earlier in the question? I didn't have. It means that I have added 3 square on the left hand side. So to keep the equation balanced, I will have to add 3 square on the right hand side as well. This is a new term that we have added. Okay, this b square, this 3 square that we see is a new term that has been added, which is why it is added to both sides. And of course, we have this minus 27 here. Now, because of the addition of this 3 square, you will notice that the first three, right? The first three terms that you see here are of the form a square plus 2ab plus b square, which is a plus b the whole square minus 27 is equal to 3 square is 9. Now shift that minus 27 to the other side. I get x plus 3 the whole square is equal to 27 plus 9 is 36, which means x plus 3 is square root of 36, right, with a plus or minus sign. And therefore, I can say that x plus 3 is either positive 6 or x plus 3 is negative 6. This means that x equals 3 or x equals negative 9, right? And this is how we get the values for x. So the idea here is that completing the square, we first split this middle term. So let us quickly write down what all we did. We first make sure that coefficient of x square is 1. Then we split the middle term. We split the middle term in the form 2ab. If you notice, I split this middle term as 2ab, right? And then I found out my b, and then I add the b square on both sides. I add b square on both sides, and then I get either a plus b the whole square or a minus b the whole square. And then solving the quadratic equation is quite simple. So I'll just pause for a minute for you to take a look at this, and then let me solve many more questions based on completing the square method. Now, of course, there can be some questions like what if the coefficient of x square was not 1? And what if the middle term was not an even number? So we will deal with all such questions in the remaining part of today's session. Okay, let us now solve the second question. Let us now solve these two questions. Let's check if the coefficient of x square is 1. Yes, it is 1. So we will write this as x square minus 2 times x times. And now we have to find the number over here, right? So that when I multiply, I get a 1 here. So if you notice, the coefficient of x is 1 right now. So 1, to get a 1, I should definitely divide this 1 by 2 and write it here. So this is half. Let's quickly check. 2 into half becomes 1, right? So 2 and 2 would cancel and I would get x back again, which means that my b is half, right? So we have in this particular step, we found that b is equal to half. So now let's complete the square, meaning I have a square minus 2 times a times b, and then let me add b square, that is let me add half square so that I can complete the square. Initially I only had a square minus 2ab, the b square was missing, and this half square has been added on both sides, right? And then I have minus 30 over here in the left hand side. Now of course the first three terms make a very nice square, so I can write this as x minus half the whole square. Shift the 30 to the other side, I get 30 plus 1 by 4, and therefore x minus half the whole square is equal to, if I take the LCM, it becomes 121 divided by 4, right? And therefore I can say x minus half is equal to square root of 121 by 4. So let us find that now. This means x minus half is equal to square root of 121 is 11 divided by square root of 4 is 2, and I'm going to have a plus or minus sign. This means x minus half is 11 by 2, or x minus half is minus 11 by 2, which means x equals half plus 11 by 2, or x equals half minus 11 by 2. And therefore x is 12 by 2, which is 6, or x is minus 10 by 2 is minus 5, right? So these are the two values of x that I get from this particular quadratic equation. So let us quickly recap what steps we had rather than what the strategy was. So I first found b in this step, and then I added b squared to both sides. Add b squared to both sides, right? And when I add b squared to both sides, I first wrote the complete square here. So this is the complete square, and I shifted all the other terms to the right hand side and I merged them. So over here, because this involves addition with fractions, I found the LCM and I merged the terms, yeah. And then I shifted the square to the other side as square root, right? This is what I did here. And then I wrote the two equations separately. So this is equation 1 with a positive 11 by 2 as the root, and this is equation 2 with a negative 11 by 2, and then I simplified for the value of x. So now let us solve x square minus 5x minus 24 equal to 0. Let me just pause for a minute so that you can take a look at this, and then we will continue. Okay, let us now solve the next question. So I have x square minus 5x minus 24 equal to 0. Again, the coefficient of x square is 1. That's good. So this would be x square minus 2 into x into. Now I should write a term over here so that I get a 5 back. It's not difficult to notice that it is 5 upon 2, right? And then I should be adding then this is minus 24 is equal to 0. So now what we are going to do is, I have found out that my b is equal to 5 by 2, right? So because b is equal to 5 by 2, I should be adding 5 by 2 square on both sides. So this becomes x square minus 2 into x into 5 by 2 Again, to find the b, you will notice that I just took the middle number and I divided it by 2. So because I have written a 2 over here. So 2 into x into 5 by 2. Let's add b square. That's 5 by 2 the whole square on both sides. So 5 by 2 the whole square. And then I have a minus 24 here. The first three terms are forming my square. So that means x minus, because there's a minus sign here, it means this is minus 2ab. So this is x minus 5 by 2 the whole square is equal to, let's shift the 24 to the other side. So 24 plus 5 square becomes 25 divided by 4. 5 by 2 the whole square is 25 by 4, which means x minus 5 by 2 the whole square is equal to 96 plus 25 is 121 by 4. And now I can find the square root on both sides. So x minus 5 by 2 is equal to square root of 121 by 4, root 121 by 4, which means x minus 5 by 2 is 11 by 2, of course with a positive or negative sign, which means x minus 5 by 2 is 11 by 2, or x minus 5 by 2 is minus 11 by 2. And therefore, x is equal to 11 by 2 plus 5 by 2, or x is equal to 5 by 2 minus 11 by 2. And therefore, x becomes 11 plus 5 is 16 by 2 is 8, or x is equal to 5 minus 11 is minus 6, minus 6 by 2 is minus 3. Therefore, the roots are 8 or minus 3. Yeah, so again let me pause for a minute so that you can take a look at this and then we will continue. Okay, let us take up the next set of questions now. Okay, let us consider that we have these four equations to solve. Let us now solve them. The first equation is 9x square. So let's start from here. 9x square minus 15x plus 6 equal to 0. I notice that I can divide everything by 3, right? All the numbers are divisible by 3. So let's divide by 3. I get 3x square minus 5x plus 2 is equal to 0. Now, for completing the square method, the first check was if the coefficient of x square is 1. It looks like the coefficient of x square is 3 here. So let us now divide both sides by 3. So dividing both sides by 3, we get x square minus 5x by 3 plus 2 by 3 is equal to 0, right? So I have divided all the terms by 3. 3x square by 3 gave me x square, 5x by 3 gave me 5x by 3, and 2 divided by 3 gave me 2 by 3. So now I have x square minus 2 into a, and now I should find b, isn't it? So to find b, what I will do is I will multiply the denominator by 2. So this becomes 5 upon 6, right? So a quick check, 2 into 5 by 6. So if you simplify 2 and 5 by 6, you get 5 by 3, which is the middle term, right? So this 5 by 6 is correct. Plus 2 by 3 is equal to 0. Again, just to repeat, when I had to split the term, I split 5 by 3x as 2 into x into, and then I just multiplied the denominator by 2, which is 5 by 6, right? So 2 and 6 cancels to 3, and this is how you get 5x by 3. So now it's time to I have found my b in this step. Time to complete the square now. So we get x square minus 2 into x into 5 by 6 plus 5 by 6 the whole square is equal to, on the other side also you will have 5 by 6 the whole square plus 2 by 3. Now these first three terms make up x minus 5 by 6 the whole square plus 2 by 3 is equal to, if you open this you will get 25 by 36, square of 5 and 6. Let's shift the 2 by 3 to the other side. So we get x minus 5 by 6 the whole square is equal to 25 by 36 minus 2 by 3. Of course, I can take the LCM on the other side. So x minus 5 by 6 the whole square is 25 minus 24 is 1. If I take the LCM, 1 upon 36. Right? And this implies that I can now take the square root on both sides. So let's quickly take the square root on both sides. So square root of 1 by 36 is going to be 1 by 6. So I can say that, just a minute. Yeah. So I can say that x minus 5 by 6 is root of 1 by 36, which is plus or minus 1 by 6. So I can say x minus 5 by 6 is 1 by 6, or x minus 5 by 6 is minus 1 by 6, which means x is equal to 5 by 6 plus 1 by 6, or x is equal to 5 by 6 minus 1 by 6. Therefore, x is 5 plus 1 is 6 by 6 is 1, or x is 5 minus 1 is 4, 4 by 6 is 2 by 3, right? Therefore, the two solutions for x are 1 and 2 by 3. Again, over here, if I were to summarize the steps or summarize the process, I first made sure that the coefficient of x square is 1, right? For that, I had to divide the whole equation by 3. Then I started completing the square. So first I figured out my b over here. If you notice, I figured out my b here. The coefficient of x square is 1 here. And then I added a b square here. If you notice, b square has been added on both sides. And then I completed the square, and then it was just calculation of the numbers. Yeah. So this is how I go with this particular problem. Let me pause for a minute, and then we move on to the next question. Okay, let us solve the next question now. So the equation under consideration right now is 2x square minus 5x plus 3 equal to 0. Okay, coefficient of x square is not 1. So let's divide throughout by 2. Divide throughout by 2. So we get x square minus 5x by 2 plus 3 by 2 is equal to 0. And therefore, we can now write this as x square minus 2 times x times. We need to figure out the b. So I have 5 by 2 here. Let me divide the denominator by 2. So it will become 5 by 4. So times 5 by 4 plus 3 by 2 is equal to 0. Let me do a quick check. If I cancel 2 and 4, I will get 5x by 2, which matches my middle term. So this splitting is correct. Now I need to add the b square to both sides. So 2 into x into 5 by 4 plus 5 by 4 the whole square. Add it on both sides. And then there's a plus 3 by 2. Now the first three terms are x minus 5 by 4 the whole square. Y minus, because this is of the form a square minus 2ab plus b square, plus 3 upon 2 is equal to 5 by 4 the whole square, which means x minus 5 by 4 the whole square is equal to 5 by 4 the whole square minus 3 by 2. And therefore x minus 5 by 4 the whole square is equal to 25 by 16 minus 3 by 2. This means x minus 5 by 4 the whole square is equal to, I can now take the LCM is 16. So I need to multiply both sides by 8. So 25 minus 24, which is going to be 1. Therefore, x minus 5 by 4 the whole square is 1 by 16, which in turn means x minus 5 by 4 is either 1 by 4 or x minus 5 by 4 is minus 1 by 4. This means x is equal to, shift the 5 to the other side, it becomes 5 by 4 plus 1 by 4, or x is 5 by 4 minus 1 by 4, which means x is equal to 6 by 4 is 3 by 2, or 5 minus 1 is 4, 4 by 4 is 1. Therefore, the value of x is either 3 by 2 or 1. This is how we solve this particular quadratic equation. So again, pausing for a minute before I move on. Moving on to the next question. So here the equation under consideration now is 5x square minus 6x. So 5x square minus 6x minus 2 is equal to 0. Let's divide both equations. Divide both equations by 5. We get x square minus 6x upon 5 minus 2 upon 5 is equal to 0. So this can be written as a square minus 2 into a into b. B is 3 upon 5. Right? Now how did I find that out? Because I said that we can either, okay, so let me show you this one. So the way I did this was I multiplied the denominator by 2. So it would become 6 upon 10, isn't it? Right? And 6 upon 10 can be simplified by 2 and it can be written as 3 upon 5. That is why if your numerator is an even number, then you can just divide the numerator by 2. But if your numerator is odd, you multiply the denominator by 2, right? And that is how you get the middle term. So let's do a quick check. 2 into 3 is 6. So 6x by 5, and that matches my middle term. Minus 2 by 3 is equal to 0. Now to complete the square, I should add 3 by 5 the whole square to both sides. So x square minus 2x into 3 by 5 plus 3 by 5 the whole square on both sides, 3 by 5 the whole square minus 2 upon 3. So this part now becomes x minus 3 by 5 the whole square is equal to, let's transpose the 2 by 3 to the other side. So 2 by 3 plus 9 by 25. And now we can find out the LCM here. The LCM here is going to be 75. And 2 into 25 is 50. So 50 plus something went wrong over here. Let's quickly check what went wrong. Yes, so instead of 2 by 5, I had taken 2 by 3. So let's be careful here. This is 2 by 5 and 2 by 5 plus 25. So now if I combine these two terms, let's see what I get. So now 25 is the LCM and 2 into 5 is 10. 10 plus 9 is 19. So I get x minus 3 by 5 the whole square is equal to 19 by 25, which means x minus 3 by 5 is equal to square root of 19 by 25, of course with a plus or minus sign. And therefore x is equal to, so let's make a partition here. Therefore x is equal to 3 by 5 plus or minus root of 19 by 25, which can be written as 3 by 5 plus or minus root 19 upon 5, right? And therefore x will be 3 plus root 19 by 5, or x will be 3 minus root 19 divided by 5, right? These are the two roots to my quadratic equation. So sometimes the square root part will not vanish. For example, 19 over here, the square root of 19 remains square root of 19, which is fine. As long as it's a real number, it should be perfectly okay. Yeah. So this is how we solve this particular quadratic equation. Again, pausing for a minute. Generally, you have to really understand how to find the value of b. Once you understand how to find the value of b, the procedure is quite mechanical. Okay, so let us now solve the next question. Okay, so we have 4x square plus 3x plus 5 equal to 0. Let us divide throughout by 4. So dividing throughout by 4. What we now get is 4x square by 4 is x square, and this becomes 3 by 4x, and then you have a 5 by 4 equal to 0. So this means this is of the form a square plus 2 into x into the b part is 3 upon 8 now. Do you understand why? Because I have divided the denominator, I have multiplied the denominator by 2, which means 4 into 2 would become 8, and that's why I have 3 by 8 plus 5 by 4 is equal to 0. So this becomes x square plus 2 into x into 3 upon 8, and let's add 3 upon 8 the whole square to both sides, right? And then I have plus 5 by 4. So now we have completed the square. So this is x plus 3 by 8 the whole square plus 5 by 4 is equal to 9 by 64. Do you now realize why this method is called completing the square method? Because we are first figuring out b and then we are adding b square, and that is completing the a plus b the whole square or a minus b the whole square depending on the sign. So We are manipulating the terms to complete that square, which is why this method is called completing the square method. So this is x plus 3 by 8 the whole square is 9 by 64 minus 5 by 4. This means this is x plus 3 by 8 the whole square is equal to 9 minus, I need to multiply this by 16. So 5 16s are 80 upon 64. That means x plus 3 by 8 the whole square is equal to negative 71 by 64. And therefore x plus 3 by 8 is square root of negative 71 by 64. This means I cannot find the square root of a negative number, right? So this is plus or minus root 71 by 8. So x plus 3 by 8 is equal to so much, which means x is negative 3 by 8 plus or minus root of negative 71 by 8. You will notice that finding square root of negative numbers is not going to give you a real number. Such numbers are called complex numbers or imaginary numbers, which will be introduced to you in the further standards. Therefore, I can say that x is minus 3 plus under root negative 71 by 8, or x is equal to minus 3 minus under root negative 71 by 8. These roots are called imaginary roots because square root of negative 71 is a imaginary number. It's not a real number. So later on you will learn more things about nature of roots, like discriminant and nature of roots. And in nature of roots, one nature of root is an imaginary root. So this is an example where you actually have an imaginary root, because finding square root of negative numbers is not possible. So completing the square method can definitely help you find real roots as well as imaginary roots. In the all previous examples had real roots. Real roots mean they are real numbers, whereas over here you have a number which is not real. Root negative 71 is not a real number. So completing the square method certainly helps you find the roots, whether they are real or whether they are imaginary. So this is how we use completing the square method. Now let me give you a few questions to solve, and I'll give you the answers as well. Yeah. Pausing for a minute for you to grasp this particular problem. So these are the questions for you to solve. I'll leave the screen for another 5 minutes, and we conclude today's session over here. You can write down all the questions or take a snap of this particular picture. Okay, we conclude today's session. I hope you understood the concept of completing the square method.